Okay, yeah, sorry for that interruption. That's annoying. I hate it. But anyhow, just to make it very clear, again, I'm trying to say you can do this with fridge magnets. Like I showed in the previous video, I had a couple magnets, like how the magnetism likes to flow in one direction. That's why you have the north-south connection. When it's all going in one direction, then it's great. When they're both having the directions of their magnetism facing each other, they oppose because they're not all flowing. So that's why this works. So anyone wanting to say that this doesn't work, one, I already showed in the other video, I have my own at home. It's a desktop toy. It's very basic. Easy to understand how it works. You can even make this with, again, fridge magnets at home with popsicle sticks if you want. It will be less stable, maybe, but you can make them. And like, it'd be cool to have magnets that are so powerful with neodymium magnets. And again, there's no batteries in this. It's really
Tamba Puliata, Venezuela. A greeting to him from Canal Angelito and from myself too. And how does this work?
This is important. Mine's the same.
Notice that here there's a sheet metal bent into an L shape,
or just something to help
to which I've made some
control.
small dots marked with a dot, so
There
that
is some amount.
It can stay there.
So when you have one of these things, and there's a magnet in this one, it should be in that one also. I'm missing that magnet. I need to find it. I don't know where it ended up. And it wasn't underneath my bed because I literally removed my entire bed. And I still didn't find it. Please help. However, the point is, with this setup, if you had a second magnet in there, it levitates just fine. And like the little bit of acrylic there or whatever to stop it, it doesn't have to be metal. It can just be something. And then, like, I'm holding up one end of it, but the other end is held up by the magnet. So you could, like, spin it. It'd be a lot nicer if I had a complete version, but it does work. So that's interesting. His is, the assumption with this and everything is that it's for, and specifically, it is these round magnets. It's just mine are very much smaller than his. And it does make, first of all, for a nice free spinning motion. And then if you could also hold that in place with magnetism, instead of needing to, or some kind of, I don't know. I hear about air syringes. I don't think you can do an air syringe type levitation, bulb, like a bearing type thing, sideways. I don't know if that works. I know it works vertically, but not sideways. This is very sideways construction. But yeah, once you have it working, it'll just spin.
This way the magnets repel.
Yeah.
We have to find the position.
Yeah.
For example, here it sticks or
Attracts.
This is attracted, but if I turn it over it moves away.
If I literally turn this the other way around, it'll be stuck.
Versus, so we have to choose the side that goes to each side so that it repels.
Or the correct way so
this
that it operates.
Be inverted, like this.
It'll be repulsive.
Good. This is what we have.
And here. I love that. It's so.
Now, how do we calibrate the magnet in the back?
Again, if
The
people are
one that would
telling
be
you this is
floating,
fake,
let's say
they're
this
dumb.
magnet,
I have one of these.
goes well in line with the others in a single line.
Anyone with fridge magnets can tell you can make.
If you see it from here, it is in a single line and the magnet in front is slightly displaced towards the side where the support point will be.
Yeah.
Why?
Now,
Because if it's here, it can escape to this side, because since it repels in all forms, you have to try to repel it to the side where it's supported, and since it can't get past there because it's supported, it stays in the air.
here's the thing. The magnetic field is flowing in that direction towards there. So, as long as the magnetic field lines are slightly askewed, like it's always going to want to push towards that stopping plate. So I have like in my example, the toy that I have there's a stopping plate there. My assumption is that yeah, you can make this with much more powerful magnets. You could make it so that it works the so it has some amount of force to be able to lift things, but the problem is how much force. So obviously with any magnetic system, you don't need to have this kind of setup. You just need you don't need to be complex. You just need two magnets with any opposing forces on top of each other, held without the ability to like shift position. And the up and down force will always be there. And it'll be like um, it'll be like having a magnetic field just holding you up. So what you could do with cars, you could just put cars on caster wheels and then have the magnetic field, like basically you have the same kind of stuff that you have on a regular car, but instead for some reason you would have this thing to be like a gap between. Now, there's a bunch of reasons why that doesn't really work well for cars. It really does need to be unable to move sideways or sideways. The moving up and down is the main thing that's mediated, and it's stiff. It's not a suspension thing like springs can do, but it's really stiff. Like, not a lot of use for that. It's not the same as actually making a levitating car, and yeah, you could make it. You could make the piston setup so that there are magnetic stuff that is the only thing that is holding between you and the ground. This is another reason why you don't really want to do it with cars, and the whole caster idea is, well, okay, you could do it. You would just have to have wires leading down to the ground part, which is the caster wheels. Like, it's a weird construction. It's not the most stable construction. I can't really imagine why you want something that levitates like even like a foot off the ground with whatever stationary magnets. These don't have to be electric magnets at all. They can't fridge magnets. But like you can make big powerful neodymium magnets. It'd be very expensive. But um I think someone else did a much better video talking about it. It's just not the problem is there's not a lot of use case. It just provides like like perhaps it would be good to have magnetic repulsion like this. Um, Maybe in a laboratory where you want to have everything like be like really stable or level, perhaps. I don't know. I doubt that. And the thing is, earthquakes will still translate through the magnetic field. So, like, any amount of push on the bottom magnet was going to push on the top magnet with equal force. I mean, they can only compress so much. So, I find the problem is, even though it can work and does work, I can literally have one example of this. The question is it any use? And I don't genuinely know. That's the problem. It's like it does it have a purpose? And stuff like, could you use this for um, a magnetically levitated spindle? I mean, yeah. Then you don't need ball bearings, and you could use this type of thing. Stationary magnets. You don't have to power it to make it work. So the thing that you're doing, yeah, it'll spin, and it doesn't even like stay put because they're circular magnets instead of like it's different with flat magnets. Because it's circular magnets, the magnetic field lines are the same throughout the magnet. So it's a toroid instead of like with flat bar magnets. It's a different kind of magnetic field. It's like if you were to take the flat bar magnet and just stretch it into so that the north side is on one side of this circle and the south side is on the other side of the circle. With bar magnets, it's very much that it's usually one pole, one specific end of the pole, or the top and bottom. And it's different when you have it in this kind of configuration, I think, for some reason that I can't really quite put my finger on. Just because I can't explain it doesn't mean like I literally have it. So like,
You can also do it with just one magnet.
yeah,
If I take this magnet out and I have this, the pen with just one, you have to correct this part a little bit and go further in, and it'll also be
yeah.
left with just one.
So yeah, that's the exact same thing I
In other
have
words,
because I only
if
have
you're
one
missing
of
a
the
magnet,
two
it
magnets
works
in
the
the
same
toy.
with just one.
So like, if you want to use it as
And it can spin for a long time like that because the support point is very, very small.
yeah, very little
It's the tip of
friction
the
in
pen,
that.
which is
But
a
if you
small ball and there's almost no friction, so it keeps spinning for quite a long time even when you barely move it.
yeah, the thing is also again, it's very susceptible to any
Here you
counter
can see the
motion.
movement.
So like, you could stop it with
We're
your
going to
bare
put it on its
fingers, no
side.
problem. Even if you have like a flywheel attached to it, like you can get that started. Its own momentum and stuff will try to move it away from the magnetic levitation guiding lines.
And there you can
But
see the little dots that are barely marked so that the tip of the pen can
there are
go in there and
easier
stay there
ways to
without slipping.
construct magnetic bearings.
If it doesn't, it slips.
This is just a basic experiment. It's not super refined.
It's especially for science fairs or physics classes in schools.
Yeah, I wish I had this when I was in school. I would have showed it at...
It's a simple little gadget that doesn't cost much to make and can help you get a good grade.
Yeah, that's about it, though. Like,
Well, friends, that's all for this video. Remember that here on Canal...
so the thing is, again, I'm saying this for real. This does work, it's just extremely limited use. Like, you can use just stationary magnets. And again, people with neodymium magnets, I've seen like a cheese wheel sized, like a good sized neodymium magnet. It has some hefty power to it. So to keep it lined up, you gotta have some pretty good structural support to like hold it in place, and like a proper amount of, like, it depends. The heavier power in the magnet, the more support you're going to need. So ironically, while you're trying to levitate something, you're going to also have to make sure that it doesn't move. And it's like, it's this whole thing, like at that point, why don't you just have legs on it? And it's like, it might be good for experiments. It might be good for certain scenarios that I can't put my finger on, like sensitivity testing. Um, can use it as a power source. Here's the thing. With the magnetic fields that are being produced here, there's a reason there's a board there. There's this straight edge that's holding it from going further that way, right? And it's because there is some amount of magnetic fields flowing in that direction and pushing it all that way. So the thing about that is that there is a bit of force that can be exerted from this. Now, if you were to say, for just somehow, I've already said this in other videos, if you had put one of these things on, like, let's say you put the bottom half on a movable skateboard or whatever, and you put the top half so that it can press, I mean, it's not going to exert force relative to the thing, but if you have it like it'll just hold itself there. It's not like on its own it's going to apply a force that's going to lead to like thrust or anything. That's not what I'm saying. What I'm saying is if you have like a specific, what I imagine could work is it can move a little bit towards that bar and not leave, right? Not so if you were able to, you should be able to have some amount of that force applied, and then because it applied a similar type, like a different kind of mechanism, would make it so that it moves the bottom part a little bit forward on a track, a nice long track. And I've seen some systems that are sort of like this, but it's like very specific, very deliberately made and done. And with the magnetic repulsion, you would just, like, the thing is, like, you would think they would just press against each other and they would just be stationary all the time. I'm going to move back to my chair and turn on a light. So I'm stuck because the idea that is in my head is that if you wanted to, there's got to be some way to make these kinds of magnets or any whatever magnetic force so that you could push it and it'll move constantly because the electromagnetic field is already moving in that direction anyway. But then you have to make it in a specific way that it also allows for that motion to then transfer to something else. And the major problem that most people come up with is that the amount of magnetic force that you're able to apply and keep it moving in this somehow fashion that I can't quite figure out. If you were to try to use that to power anything, chances are, like, the only way it would work is if you didn't have, if the magnetic field was powerful enough to overcome the friction, the electromagnetic friction of the generator itself, right? So the more power you try to generate with it, the more energy is made in that generator, which causes a kind of like just the same idea as regenerative braking, right? That motion causes the power to be made, but in doing so, it makes equal opposite, like, resistive forces. So the magnetic stationary forces have to be strong enough that whatever coil you're using to generate power, you balance it so that it's not making so much power that you overcome the magnetic force that you're applying in the first place. And again, if you have a bunch of stationary magnets that you can just spend towards this, you could make a system that will just keep pushing that thing forward constantly on some kind of a track that'll move a thing, that'll generate power. And the problem is it'll generate like a small amount of power. And again, these aren't going to lose power for 100 years. They'll lose like 10% over 100 years is what they project. So it's kind of like you could make a generator. The question is all this infrastructure to make something that generates how much power? And a basic, very bare back of the napkin, not even back of the napkin. Just me thinking off the top of my head, I can't imagine this type of thing could be used to make a lot of power. Like, it's not solving world energy crisis on its own as it stands. But here's the thing. I don't know enough about neodymium magnets. I hear that some of them have like 100 pounds of force just on their own. They're huge, they're powerful, and just the bigger the neodymium magnets are, the more powerful they are. They're just standing magnets. They're just massive fridge magnets that have no electromagnetic force whatsoever. It's all just the magnetic force that's already in them. So I'm pretty sure they're made initially with neodymium ones. You charge them with a supercharger that provides like tons of amps into them, and they're charged like over entire weeks. Um, so the main thing you want to think of is how much power can you utilize them for, and then at some point be able to charge these magnets to become stronger. I mean, you got 100 years to charge it. Usually it takes weeks to charge it. The question is, in that 100 years time, how much power can you get from a system that you can make out of this? Right? Neodymium being the strongest magnets I'm aware of, or the strongest ones that are stationary, not electromagnetic, that I know of. Like, what's the most power that you can even derive from a system like this? And the problem is, people are going to say you can't generate anything. But there is, obviously, like anyone would tell you, you put the same charge magnets, they have a repulsive force. So the question is there not any way to maximize on that repulsive force? And I know there has to be some. The problem is, my brain is like, there has to be a way. You might not be able to do it with bar magnets, but round magnets, perhaps. Magnets like this one. Now, the main thing that comes to mind is that relative to this entire setup, the motion can't be a lot. But it exerts a force, right? So if that force was allowed to move and then tick, and then for whatever other reason you have a separate force moving the bottom one so that it can tick forward while the other magnets are stationary, the bar is let to reset for some reason. Like, let's say there's a weight that's holding it so that it's pressed, but then the magnetic force wants to push it this way, right? You would let it push it this way while you hold the weight, and then like one magnetic force pushing it this way so it's able to move forward, another magnetic force able to push it the other way so it's able to move back. Or something. And it's that problem of figuring out how to make a system that can repeat itself, or a system that can perpetuate, like continuous motion. People don't like perpetuated motion. Uninterrupted motion, or like jittery click, 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 and it keeps on going. Because relative to each other, these magnets can't move very much different to where they already are. That's how the magnetic field lines work in these round magnets. So the question is, what kind of constructions can you make? What kind of motions can you make? And That's the thing. Again, if all it takes is positive and negative magnetic fields, or magnetic fields that are pushing against, like it could be electrically charged wire. It just doesn't have to be. But the main idea is that it like it doesn't matter, because if you add the power back into the electromagnetism to power the coils, it's their power plus the repulsion with the stationary magnets. And it's the fact that the stationary magnets are stationary that lets you be able to make something like, I saw someone make a train, like a little, they put a little magnet on to the front and the back of a battery, and they put that into like a tube of conductive coil so it could go in a circle. And that only works because, again, the electricity from all that is powering the magnets. But again, magnets on their own have their own magnetic force. The question, they have their own magnetic repulsion. So like any amount or any structure where you have one opposing negative or opposing either both negative or both positive magnetic forces, there's just got to be a way. And this is the problem, is that my brain is going to the next video trying to think about how to make this into a machine that works and constantly makes power and is not gonna like break the bank, or is also gonna make a certain amount of power that's actually like worth it, right? Because they're pushing, because if they're able to push at all, then they would push in one direction. And the thing is, can you make it so it can repeat? Now, here's the thing. Real big kicker about all of this. Veritasium did a video. We're in a new age of industrial bullshit because of what Veritasium did with spring. Now, where's that spring? I don't fucking know. There it is. The mechanism that shrinks when pulled. So you can have it so that this type of mechanism does the repeating part, where with a certain amount of force, it's able to do the pulling back of the magnet so that you've applied the force and then make a way so that it then has the force able to be passively resetting with just a weight that helps it reset, a specific weight that helps it reset. But like, and the problem is, again, this very machine, and this is again a real machine that works, could be used to make a water pump or a machine like this with magnets. And really, just a water pump is enough that you have, if you're able to make something like this specific, this device, um, down here. If you're able to make that into the way it would best work, okay, and I've already explained this in a different video, is that you would have, let's say you have a cup of water, right? You want to move it somewhere else. Well, you'd have one of these things set up so that when you have the top amount of water, right, and it wouldn't fill too much, otherwise it would pull it down too much. But you fill it up so that it's just enough. You have a stopper so it doesn't just release whenever. You release it when you have the right amount of water. And then once you have it at that level, just release it. This machine will pull it up. And then once you're at its height, you stop the motion again. And then it will drain whatever hose you have on it, whatever. And depending on how it's designed, it could like lift it up a few feet or whatever. Who cares? The point is, once it's up there, you have that drain, and then it's able to have that water at a higher height be able to go somewhere else, right? And then you let it, once it's low enough that it's not pulling on it hard enough to engage the other springs, it will naturally lower itself back down. Then you lock it in place, you fill it up again, and it forces the recoil again, lifting it up, you lock it in place, you repeat the process. And that is a perpetual motion machine that fucking works. And I want you to give me a Nobel Prize for that. But add in the fact that you have these magnets involved. I mean, the magnets, well, you don't even need the magnets to do this. So what's the benefit of having the ability to flow water up and down in a manner that, well, first of all, you got to think about the wear and tear of all these machines and whatever else. But considering if you make something that is able to be consistent or whatever, and the best thing is because it is reversible, easily, you could make a system like this so that it can flow the water. Now here's the problem, right? Upscaling. Going from a machine that is obviously a hand-sized machine with very limited practical use. This actually, if you could make just thousands of them or millions of them or a big version of them, which is much better, then like if you just make, the whole thing is based off the idea of springs in parallel and springs in series. Because if you have two springs working together, the force is felt by both of them, or the stretching is felt by both of them, or whatever weight you have is felt by both of them. So you have less ability to stretch when you're working together, and more ability to stretch when they're working. The whole video explains it very well, and I'm crap at that. But the basic thing is applying those type of physics things, whether it's a springs in tandem or in series and in parallel. With this mechanism, it's an easy switching from one to the other. So you can make a small machine like this, but you could make a large machine like this. The thing about a larger machine is it's harder to make something that is capable of continuously repeating. But let's say literally any amount of springs that you just have them all working separately, and then you have some of them working together. You can repeat the process so it can cycle. It can be on part of it can be that the motion of moving up and down also pulls on something. So you have an extra amount of like maybe you can pull on something as you're moving down, because the resistive force of going down is that it'll relax and go down. Maybe it relaxes and goes down, and the weight is able to pull something down, right? And then similar, the weight and everything else can be used to pull everything up. Like, I'm not saying use this type of spring mechanism for an elevator of like people or rocket ships or anything crazy like that. But using it as a pump mechanism feels like something that should be able to be made and repeating and be able to be something that is like it will just work. The most dangerous escalator was an interesting thing because it all has to do with escalators being like their drivetrain is made it powered by an engine that's like super strong. It's capable of holding all the people that you could ever think of. But the moment you go over its weight tolerance, it's like, oh shit, can't keep moving. It's gonna just slide all the way down and run away. And it's like that's not good. So it's like you would think that you would be able to make instead of like imagine if you had cantilevers that somehow, and this does not easily work, you'd be able to make it so that the weight of the whole thing wouldn't just go downwards, but it would also, like, if you're on the other side of the escalator, people on the other side going up would help with the weight of the people going down to balance it. But you wouldn't need people, you could just have an underground system like that so that the motion is able to mitigate the amount of force applied to like brakes or some bullshit. Because, like, that's nutty. Come on. Just have some other kind of resistive braking than simple, like, electromagnetism. You could use, um, like, actual other weights to hold everything so that it'll only move if you let it move, you know? But it's like, the drivetrain and tension and everything, and it's like it would be pulled from both sides. It would be crazy. And it's interesting that people going down the escalator is generating power while people going up the escalator is using power more. Like you gotta slow it down, but in general, the more people adding their weight to it would increase the amount of power that is generated. And they mentioned that in that video, and that's cool. The problem is Veritasium doesn't even realize this can be used as a perpetual motion machine. This this guy's thing, like the problem with it, again, I have the exact same, a small scale version of it, and I just struggle in my brain. Like I can think of a few ways. Like you can use it as a bearing, kind of. Magnetic bearing is really useful for a lot of things. Um, it's just, I think if you should be able to use that amount of force that you have there too. Also, random thought, totally separate. What if, has there ever been, are there electric cars where you use like a diesel engine generator type of thing that you could use um, to like power? If you wanted to, you could just fill that up at the gas tank and then be able to charge like anywhere that you're parked. Just turn that on and it would just charge your car so you could then go somewhere else. You don't have to plug into the grid. You could just use diesel. Now that you would think that that would bypass the need of having an electric car in the first place, but electric diesel generator, its own, like it doesn't have to be as heavy and powerful as the engines that power the car. It just has to be powerful enough to charge the battery. And I imagine a diesel generator, I mean, it would make the car heavier, but, and obviously there are ways of making it less loud or whatever. Like you can figure out that. But like, imagine you had that, right? Like the odd thing of using the battery in the first place to store the power of the electric diesel generator versus that same engine used to power the car in the first place. You'd end up wondering like, well, clearly you don't need as much of, I would assume you don't need as much to make it work the other way. The other idea is to have like freaking nuclear powered cars. It's like, oh, you just have a little nuclear generator in your car. That kind of thing moving around, not exactly the thinking that's the best idea, although they have subs with nuclear generators. So it's like, you gotta think it's gotta be somewhat viable. Just, I think cars are more inertial, so they're much less smooth a ride than a submarine. So there's that. Or you you end up wondering, like, would the bumpiness of a car ride make it be more reactive, so it's more efficient than a nuclear sub? But like the safety stuff on it, the fact that you don't want it to ever fail and all that, Mr. Fusion. Um, my mattress is dipping, and that doesn't make any sense because it's supported by like a frame that's straight and everything, but it's dipping, and I'm like, that defeats the purpose of like a proper frame. Well, I've went on a tangent and then some. I don't know why I didn't watch you other stuff. But yeah, hey Derek, that spring thing, like it's literally the difference between like individual springs will feel whatever amount of pull independently, right? So working together, obviously they have a stronger amount of strength to be able to pull things up. So all of that logic is sound. It makes sense. It's just, and it makes you wonder. This is 11 years old. It makes you wonder how many of these other things, like this type of thing, like it works. The question is, and I'm always stuck on, can it be used to make a power source? And I wonder why I don't make these types of experiments and figure out, like, oh, you could just buy circular magnets, right? You could just buy neodymium magnets. You could just make a system. Would a pendulum help? I can't imagine a pendulum would help because, like, the idea is that you already have like force moving things forward. A pendulum would be like the swinging back motion would be like, you would want the pendulum type stuff. And the thing with pendulums is that they like to keep on constantly moving downward, and that's what keeps them going. Because obviously, if you just had the pendulum um, stationary, it's not going to do very much. So you got to keep on moving it up and then set it going, and it'll just keep going, which is cool. Stuff like clockworks and whatever. Whatever. Check out the rest of my Science Me videos where you see neat science stuff. I wish I did better presentation.